In this video, I'm going to show you how to find the inverse of a function, and it depends on what representation of the function is given to you as. You could have a graph, you could have a table, or you can have an equation. So I'm going to first start off with graphs. If a function is presented to you in graphical representation, then the way you want to find the inverse is literally switching the x's and the y coordinates. So this is, I'm going to label this as graph of f. And so we're going to write down some points for f. So I'm going to pick some points on here. Here are some points. So we have the point 3, 0. We have the point 4, 1. We have the point 5, 4. And we have the point about 5.5 and 7. Now the notation for inverse, it looks like a little -1 where we would normally have an exponent. So to find the inverse, I'm going to do that in blue. We literally are switching the x's and the y's. So when I look at the points labeled in red for my f function, we have the point 3, 0. So on my function, my inverse function, I should have the point 0, 3. We're literally switching the x's and the y's. So 4, 1 would mean on the inverse I would have the point 1, 4. 5, 4 means on the inverse I would have the point 4, 5. And then the last point we would have 7 and then 5.5. So we're literally switching all the x's and the y's, and then we're replotting those points. So I have the point 0, 3, 1, 4, 4, 5, and then 7 and 5.5. When I connect those, I get this picture. Now because you're switching the x's and the y's, when you graph it, it's going to look like a reflection across the line y equals x. Here's my line y equals x. So let's do part B now. So this is going to be my original function in red, f, and I'm going to draw my inverse in blue. So I'm going to pick some points. I'm going to pick the point -3, 8. So that means when I plot the point on the inverse, it's going to be -8, 3. -8, -3, sorry. Now I'm going to pick the point, let's say -0, -2. So when I flip the ordered pair and I switch my x's and my y's, I'm going to have the point now -2, 0. So let's pick another point. Let's pick 3, 4 on the red. So that means when I graph it on my inverse, I'm going to have the point 4, 3. Let's do one more. Let's pick the point here, 5, 8. So when I graph it on my inverse, it's going to be 8, 5. So here is the graph of my inverse. Now, if I check to make sure it looks like a reflection across the line y equals x, when I draw my line up here of y equals x, it definitely looks like a reflection. Now, if I'm given a table, I'm literally just going to switch my x's and my y's. So here's my f function in red. I'm going to draw my g, or my f inverse function, in blue. So if -3, -2 is on f, then the point -2, -3 is on f inverse. So I'm literally just going to switch all my x's and my y's. And there's my inverse, given in table form. Okay, now when you're doing equations, you are going to, again, if you're given an equation and asked to find the inverse, you're literally going to switch your x and your y. So this is function notation for y. So really we've got y is equal to 4x minus 7. The f of x is just function notation for your output. So I'm going to switch my x and my y. So I have x is equal to 4y minus 7. And now all you have to do is resolve the equation for y. So I'm going to add 7 to both sides and divide by 4 on both sides. So this is my inverse. Now, when I write it using inverse notation, because f is the name of my function, I'm going to write it as f inverse, like this. So this is my inverse using inverse notation. Okay, next example. Same thing. We are literally just going to switch the x and the y. So this is my y using function notation. So the name of the function is g, but we know that that's our output. We're going to switch the x and the y. So I have x is equal to 2y cubed plus 5. And now I'm going to resolve this for y. So I'm going to subtract 5 from both sides. Divide both sides by 2. And now since I need to get y by itself, I'm going to do the cubed root to both sides to get rid of y cubed and just be left with y. And now if I want to write it using inverse notation, since this is the function g, I would write it like this. G inverse is the cubed root of x minus 5 over 2. There is my inverse. Okay, last example. This one's a little bit tricky. If I switch my x's and my y's, I'm going to get x is equal to negative 3y plus 1 over y minus 7. Notice I have an x in two different places, so when I replace my x with y, I have to make sure I do it in both places. So, in order to get rid of the fraction to make this easier to solve for y, you can look at it as one of two ways. You can cross multiply, or you can multiply both sides by y minus 7. It's up to you how you want to look at it. I'm going to cross multiply. Okay, now I'm going to distribute the x. I'll finish this up here. Okay, now here's where it gets a little bit confusing. Notice I have y in two different places, here and here. So it gets confusing because if students are trying to solve for y and you have it in two different places, it makes it difficult to kind of see what to do because you have an x in front of that y. So the trick is if you have y in two different places and you're trying to get y by itself, what you want to do is get anything that has a y in it on the left-hand side and anything that doesn't have a y in it on the right-hand side. So we're going to just rearrange this equation so that we get all the y's on the left and everything else on the right. So I'm going to add 3y to both sides. And I'm going to add 7x to both sides. And that way, I have everything that has a y in it on one side. So here are my y's. It's all on one side. And anything that doesn't have a y in it on the other side. Now that really helps us because now what I can do to isolate the y is factor out a y. When I factor out a y, I'm left with x plus 3, and now I've only got y in one place, and I can divide both sides by x plus 3 to isolate the y. So I can get rid of that, and I'm left with y is equal to 7x plus 1 over x plus 3. And then because we had the original function with h of x, and we're trying to find the inverse, when I write this in inverse notation, it's going to look like this, h inverse, and there is my final answer.